If we want to simplify an expression that contains multiple variables and possibly a coefficient, well, we'll simplify the root for each variable and the coefficient separately, and then we'll just multiply them all back together. So for example, we want to simplify the third root of 40 times x to the 7th times y to the 6th times z to the 11th. Now, we work out that 40 is 8 times 5. Right? 8 is a perfect cube number. Our index is 3. And so we can actually do cube root to 8. So cube root of 40, that's cube root of 8 times cube root of 5. Cube root of 8 is 2. We'll have 2 times the cube root of 5. Okay, cube root of x to the 7th. So we notice that 7 is 3 times 2 is 6, 3 times 3 is 9. 3 times 2 is the biggest multiple of 3 that's less than 7. 7 is 3 times 2 plus 1. So the third root of 7 is the third root of x squared to the third times x to the 1. That's the third root of x squared to the third times the third root of x to the 1. Third power and the third root cancel out, and we've got x squared times the third root of just x. Right, x to the power 1 is just x. And we do not need an absolute value because this is an odd root. Third root of y to the 6th. Oh, well, 6 is actually a multiple of 3. 6 is 3 times 2. So the third root of y to the 6th is the third root of y squared to the third. Third root and the third power cancel out, and we're just left with y squared. Again, no absolute value because we have an odd root. Third root of z to the 11th. Let's see, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, that's too big. So 3 times 3 is the biggest multiple of 3 that's less than 11. That's 9, and then 11 is 9 plus 2. We'll have the third root of z to the third times z to the second. So that's the third root of z to the third times the third root of z squared. Third root and third power cancel out. We're left with z to the third times the third root of z squared. Okay, now we can multiply all of those together. And because multiplication is commutative, I can put all of these factors in whatever order I want. And the order I want is to put everything that's not inside a root first. So I'll have a 2, an x squared, a y squared, and a z to the third. And then next I want everything that is inside a root. So I'll have third root of 5, third root of x, third root of z squared. And then of course I can combine all of those radicals. So I'll have 2x squared y squared z to the third times the third root of 5x z squared. And that is my final simplified expression. And again, note, no absolute values because I was taking an odd root. Okay, So that's neat. Working with the variables is pretty easy, at least if we're okay with doing division with remainder on relatively small numbers. If we factor our coefficients into primes, we can actually treat the coefficients exactly the same way we treat the variables. So in this example, we have the square root of 972 times x to the fifth, y to the third, z to the eighth, w. So 972, well, 2 goes into that. How many times? We'll do division 486 times, apparently. 486, well, 2 goes into that again. How many times? 243 times, apparently. Okay, well, 2 doesn't go into that anymore. Let's see if 3 does. Oh, yeah, 3 goes into that. How many times? 81 times. Okay, and now I know what I'm doing, because 81 is 9 times 9. 9 is 3 times 3. Another 9 is also 3 times 3. And so 972 is 2 to the second times 3 to the fifth. So when I'm taking the square root of 972, I'm taking the square root of 2 to the second times 3 to the fifth. Now, the square root of 2 to the second, that's just 2. How about the square root of 3 to the fifth? Well, 5 is 4 plus 1, right? That's 2 times 2 plus 1. So that's the square root of 3 to the power 2 times 2 plus 1. That's the square root of 3 squared squared times the square root of 3 to the 1. Square root and the squared cancel out, and we'll have 3 squared times the square root of 3, or 9 times the square root of 3. Putting these two back together, the square root of 972, I have 2 times 9 times the square root of 3. That's 18 times the square root of 3. So by going into primes, I was able to find out that 18 squared is a factor of 972 without ever having to work out what 18 squared is. When you approach a coefficient like this, it's up to you if you'd rather factor into primes or if you'd rather make a table of perfect powers and go through those on your calculator. Whichever you think is easier. For the variables, obviously we'll treat the variables like variables. We have square root of x to the fifth. So 5 is still 2 times 2 plus 1. So we've got x to the 2 times 2 plus 1. That's the square root of x squared squared times the square root of x to the 1. Square root and the squared cancel out. And this is an even root, so we do need an absolute value. Absolute value of x squared times the square root of x. Notice we didn't need to take the absolute value of 9 because we know what number 9 is. We know that 9 is a positive number, so that's not a problem for us. Square root of y to the third? Well, 3 is 1 times 2 plus 1. So this is the square root of y squared times the square root of y. Square root and the square cancel. but we need an absolute value. Okay, square root of z to the 8th. Oh, well, 8 is a multiple of 2, right? This is the square root of z to the 4 times 2. So this is the square root z to the 4th squared. And we're just left with the absolute value, z to the 4th. Again, we need an absolute value because it's an even root of an even power. Finally, square root of w. Well, there's really nothing we can do with that. W is just w to the 1st power. We'll just leave that as square root of w. Okay, again, I can put these factors together again in whatever order I want. So I'm going to take the stuff outside the roots first. So I'll have 18 times the absolute value of x squared times the absolute value of y times the absolute value of z to the 4th. And then I'm going to have the stuff inside the roots. So that's square root of 3, square root of x, square root of y, square root of w. Putting everything together, we can take the whole absolute value at once, right? If we take the absolute values first, we're multiplying together 3 positive numbers, or we could just multiply them together and make the result positive. So we'll have 18 times the absolute value, x squared y z to the 4th. And then also combining all the radicals. So square root 3x y w. So in that example and the previous example, we wrote out what we did with each variable separately. Ordinarily, we aren't going to do that in that much detail. Of course, you're welcome to split them up and write out additional detail if it helps you to keep track. But ultimately, our goal is to be able to do this in a line or two, because this will typically be a step in a much larger problem. So as an example of the way that we would typically write this, we have 4th root 18 x to the 7th, y squared, z to the 16th, w to the 9th. And I'm going to start by writing that as 4th root. 18 doesn't have any perfect 4th power factors, so I'm just going to leave 18 as it is. X to the 7th, that's x to the 1 times 4 times x to the 3rd. Right, 4 goes into 7 one time with 3 left over. Y squared, 4 doesn't go into 2 at all. Z to the 16 is just 4 times 4. So there won't be anything left over for the z. W to the power, so 9 is 2 times 4. That's 8, plus another 1. So what I've just done is split everything up into parts that are perfect 4th powers and parts that are going to need to remain inside the radical. So I can rewrite this. Each perfect 4th power gets a 4th root. So I've got the 4th root of x to the 1 to the 4th. And as I copy each factor, I'm going to check it off so I know I haven't missed anything. And then I've got the 4th root of z to the 4th to the 4th. The 4th root of w squared to the 4th. And then my remaining factors, I'm going to have a 4th root of 18 x to the third y squared w. For each of these factors, the fourth root and the fourth power cancel out. And so I'm going to be left with an absolute value, because we're taking even roots of even powers. X to the first is just x. Z to the fourth, w squared. And then the rest of that fourth root is along for the ride. Fourth root, 18 x to the third, y squared, w. And that's my whole simplified expression. So instead of separating each variable factor out and simplifying its root separately, I just worked all of them in line. Perfect fourth powers get split off. Everything else gets lumped together.